Good morning, friends. We are delighted today to host our friend, Dr. James H. Austin. James is Emeritus Professor of Neurology at the University of Colorado Health Sciences Center. He is one of the oldest and most respected experts on the links between the neurological workings of the human brain and meditation. He is the author of the book Zen and the Brain, which is, as far as I know, one of the earliest and most influential books on the topic. He is also the only real neuroscientist I know who is also a profoundly deep meditator. And he's going to be very shy and say, nah, but he's quite enlightened. And so making him a very rare master, both in neuroscience and meditation. James's other books include Selfless Insight and Zen-Brain Reflections. He's the only friend I have who doesn't use email. He and the Dalai Lama, so the two of them. and he's the only friend who writes me letters by hand because the Dalai Lama doesn't do that. Oh. So before we came here, he asked whether he should be doing the advanced or the general talk, the version of his talk. So I asked for the advanced technical version. So if it's too out there, blame me. But if it's good, it's his credit. And with that, please welcome our friend, Professor James Austin. Thank you.
Thank you, Meng, for your generous hospitality and generous welcome to this group. I have a very easy or a very difficult job talking to this group at Google. The difficult part of my job relates to your high level of intellect, which paradoxically makes it more difficult for you to understand, unless you remember, how important it is to have moments of insight. If you can remember the moments when you've had insight, when all your intellectual knowledge has failed you, but your intuition has given you a burst of understanding, then I have an easy job. So try to keep in mind those moments of insight at your desk or out of doors, when a moment of insight has clarified a problem that remained impenetrable to your high level of intellect. Meng tells me that many of you in this group have taken the course on meditation and consciousness. And so I think it's appropriate that we all start with a moment of meditation. You've already worked hard all this morning. You've gotten here. You've come here on time to this lecture. So let's start with a brief moment of meditation. The first slide is the old Taoist yin-yang symbol, and the purpose is to point out that there are two aspects the black and the white, the male and the female, the this and the that, are complementary, not antagonistic. They are both necessary to be part of the cosmic whole. You might wonder how a seemingly orthodox neurologist and academician would ever be involved in anything as esoteric as Zen Buddhism. It started when I was on sabbatical in Kyoto, Japan. I was introduced, fortunately, to an English-speaking Zen master. And this is the gate through which I entered this Rinzai Zen temple, Daitokaji, in 1974. It's an ordinary gate of the kind that we use in the West and elsewhere in the world. It operates as a unit so that the top and the bottom open simultaneously. What I'm about to describe to you as a theme throughout this talk is something that may seem unfamiliar, but here's the theme. The theme is that when we turn on our self-centered attention, we exert in a reciprocal opposite fashion our external kind of attentiveness, and contrary-wise, when we turn on our attentiveness into the external world, we dampen our resources that go into our self-centeredness. And with this introduction, let's turn to the two different kinds of meditation, the attentive art of meditation. For those of you who have handouts, this will be on the handout, so you needn't try to memorize it. But basically we start, as we did a few moments ago, by looking down, and usually at a spot in front of us, in a form of what's been called concentrative meditation. It's a more effortful kind of attentiveness. It's focused, and it's exclusive. If we're pointing down like this, we're excluding the world all around us and focusing on one point in a deliberate, one-pointed manner. Now, this requires our voluntary top-down processing, and so it is more self-referential. We're in there doing it. It's the kind of attention that can evolve later on into the absorptions, and it does involve our paying attention. This kind of attention, this kind of awareness is personalized. We are in there doing it ourselves. Now later on, after we've trained attention in a top-down manner, we move into a more receptive kind of meditation. By definition, this is more effortless. It's attentiveness that is unfocused, and it is inclusive. It will take in everything around us, front, back, top, and bottom. It's a more open, universal, bare awareness, and it expresses our involuntary attentiveness to the world around us. So it, by definition, is more other referential. If self is everything inside our skin, other is everything outside of our skin. And this is the kind of receptivity that can later shift into more insightful, intuitive modes of processing. It's called a choiceless awareness because we are not choosing to do it. It happens. So this is a more anonymous kind of awareness. Anonymous awareness. Now we have two ways of processing reality. The one we're most familiar with, and the one that's easiest to understand, is this form, the egocentric, self-centered kind of processing. If this is the person doing it and looking at an apple, these lines of sight from the apple are all coming back into the general axis of this person's attentiveness. And this person has a frame of reference looking at the outside world. This person is holding on with both hands to this frame of reference and is seeing only what he chooses to see. There's another kind of reality which is revealed to us without our being aware of it. And just as the word ego stands for self, the Greek word allo stands for other. So allocentric reality is that world that the brain perceives without our knowing that it's doing so, in which it looks out there and automatically identifies these apples and positions them in three-dimensional space in relation to each other. No lines of sight come back here to the person who is doing this kind of attentive processing. This is allocentric processing. Now, the two kinds of processing, egocentric and allocentric, are on your handout, but the important thing to realize is that they pursue different pathways in the brain. The egocentric pathway is, in a sense, the northern pathway, which proceeds in the upper part of the brain. The allocentric pathway is the pathway that proceeds from back to front through the southern part, the lower part of the brain. Next topic on your handout, and your handout has these topics arranged in a serial manner. So if you proceed from the top, you'll be getting the whole outline of this presentation. The next topic we're talking about is attention itself. William James, the American psychologist and philosopher, outlined the importance of attention, and he called it the faculty of bringing back a wandering attention over and over again, as the very root of all of our judgment, character, and will. I'm going to take a little different tack and also emphasize that not only is this a voluntary process, but that attention operates involuntarily. So let's look at the attentive brain here. And to get oriented, this is the back of the brain, and you're looking down at the top of the brain, with the right hemisphere being on your right and the left hemisphere being on your left. The nose is here. And let's look at the left hemisphere first, and you'll notice that it has a lot of fine dots in it. This is to emphasize that the left hemisphere operates in a discriminatory, fine-grained kind of processing. And when it looks out at the outside world, and this outside world is on the opposite side of the environment because things are crossed in the brain, it looks out and sees with discrimination, fine-grained discrimination. It sees and hears with fine-grained discrimination. Now you know that for most of us, almost all of us, our language ability is centered over in the left hemisphere, whereas when we're talking about attentiveness, the corresponding regions very exactly in this right hemisphere are specialized for attention. Most of the training in Zen meditation involves the training of attention. The training of attention, both top-down and bottom-up training of attention. And here we see the reason why. Because this right hemisphere, you'll notice, has a lot of spaces in between the lines. It's not a fine grain, it's more of a coarse grain kind of processing. And when it looks out into the opposite visual field, there's plenty of room between these lines for it to insert values, atmospheres of aesthetic appreciation and judgment. And yet, because it sends a message over to the left hemisphere through the corpus callosum, it enters into a bargain with the left hemisphere. It's an age-old bargain. It's been going on for millennia. And it says, in effect, left hemisphere, you can take over the responsibility of words and language and speaking and understanding language, but I'm going to co-opt everything that you see over on the right side of the world and claim it as mine. And so the right hemisphere pays attention to both sides of the outside environment. And this becomes very important because it means that the right hemisphere is poised to be receptive to the whole outside world. Many years ago, it was theorized with good evidence that these two pathways were organized into a where pathway and into a what pathway. It's now, I think, more reasonable to say that this northern route is a where is it in relation to me back in the center, and to say that the southern route is a what is it pathway that arrives at identification of the object that is seen out there. Those of you who know some anatomy will notice an interesting point about this northern route, because it goes through the angular gyrus here on its way north into the parietal lobe, and it misses the supramarginal gyrus, which is more involved in the ventral kind of attentiveness. This slide is a composite slide that shows the brain and what it perceives out there as in a theoretical way. We'll start with two of these spots up on the top part of the brain, because one of them is Intraparietal Sulcus, or the IPS. And the IPS is linked with the frontal eye field, which is in the frontal part of the brain. And the two together are our two modes of top-down attentiveness. We spoke of top-down attentiveness earlier, and it's on one of your handout tables. You'll notice that these two modes of attention are in a position to be overlapped by the egocentric pathway of processing, so that the two together, egocentricity and top-down attentiveness, are very easy to link together into one giant function. On the other hand, lower down is the temporal parietal junction, which includes the superior temporal gyrus here and the supramarginal gyrus. And it links up in the same network and circuitry with the inferior frontal cortex, which is farther forward in the brain. You're looking here, by the way, at the brain where the occipital lobe is back here, the seeing part of the cortex, whereas the frontal lobe and nose is way up here in front. Furthermore, this lower ventral pathway for attention is closer to the allocentric or the other-centered mode of processing reality, and tucked into the undersurface of the temporal lobe is a module called the FG, or the fusiform gyrus. This is a gyrus that's specialized both for color perception and for the processing of facial features. Thank you. All right, so here's this brain, and it's looking up into the outside world, and what is it seeing? Well, it's seeing 4 quadrants of vision, and let's look at them separately. Why, you might ask, is there a red rim around the lower visual field? Well, that's because the egocentric pathway, starting as it does in the upper part of the occipital lobe, is much more efficient at processing things that are below the horizon. So, upper part of the occipital lobe, more efficient at processing lower down. And ladies, there are several of you in the audience. If you are balancing a baby on your lap, it's very important for you to be using the functions that are up here, your functions of touch and proprioception, because they will help you hold that baby accurately on your lap so the baby doesn't fall. And gentlemen, if you are hammering a nail with your hammer and you hold the nail in your left hand, it's very important for you to have proprioception and touch so that you can come down with your hammer accurately on the head of the nail, because if you don't, your fingers are history. So this pathway, the egocentric pathway, is highly specialized for action, and it depends on the parietal lobe for its proprioceptive and touch skills. And notice that these objects that it handles are down close to it in its peripersonal space, in the envelope of space right around it, within reach, within reach. On the other hand, consider the allocentric pathway, starting in the lower part of the occipital lobe. Remember, things are crossed in the brain. So this part of the brain is most efficient at processing items that are up here in the upper visual fields, above the visual horizon. What is up here? Well, in ages past, it would be very handy to detect this saber-toothed tiger by your sense of hearing, audition, or your sense of color vision, so that you could detect the difference between the stripes on the tiger and the leaf patterns that are in the underbrush. And it's important that the tiger be detected at a distance away from you so that it doesn't wind up in your lap. And having escaped the tiger, if you wanted to be in a contemplative mode and thank your lucky stars, you could look out in the distance at the blue sky and the clouds and the mountains and be in a more relaxed frame of mind. These are the differences between vision and audition, which are in the temporal lobe, and touch and proprioception, the circuitry of which is in your parietal lobe. Now we're looking here at a functional MRI scan of the left. We're looking at the right hemisphere from the outside. The nose is here by the inferior frontal gyrus, and the occipital lobe is back here in the back. And you see these same structures that we've spoken about before, but the interesting point here is that the Intraparietal Sulcus is right next to this blue spot, which is the superior parietal lobule. What is the superior parietal lobule? It's your somatosensory association cortex. And what does that mean? It means that this is the part of your brain that understands that you have an arm, a leg, a head, and a trunk on both sides, and it puts these together so that you understand and know instinctively that you have a body that you can act with, which will be your agency for working as a unit in the outside world. So this is where your physical sense of self comes together. So notice how handy it is to have your top-down attention mode right next to this organizational principle that enables you to know you have a whole body scheme with which you can operate in the outside world. What about the bottom-up attention and its processing? Well, it's in the temporal parietal junction and the inferior frontal gyrus. And there are some yellow colors here, and that's simply to remind us that our top-down attentiveness and our bottom-up attentiveness have to be merged in a very sophisticated manner in order for us to put together the kinds of attention that we need to operate in our daily lives. So the medial frontal gyrus and the inferior frontal gyrus operate particularly on the right side to arrive at this merger of functions that enables us to operate. In your handout is a table that simply summarizes the responses of the ventral, the lower, and the dorsal kind of attention systems. And I won't dwell on that any further. It is important, however, to make a distinction, a visual distinction, between top-down attention, which is a sharply pointed, remember, exclusive kind of attention. It operates on a foundation of bare awareness. It has a pre-attention mode, which is entirely involuntary and which is right out there at the point. And the point here is simply to illustrate that top-down attention is the vanguard that is out at the tip of all of our processing. In computer programming, there's also I gather something that is out at the forefront of the processing, and in the brain, it is the sharp point of attention that impales the topic that we wish to pay attention to, so that the rest of our processing can come in and know where to operate. Think how important it is to this pen, which has lots of ink in it, to be able to have a point in order to write with. And you'll understand the pointing function of attention. And you'll understand why William James regarded it as so crucial to our operations. So this is the kind of top-down attention, and the contrasting form is our bottom-up attentiveness, which is a more global kind of receptivity. It also functions at the level of bare awareness, and it has a subconscious processing also. And everything above its threshold of consciousness, it does have the potential of entering our consciousness. But most important, everything below this level operates at a subconscious level. So that bottom-up attentiveness, much of what goes on, is not within our conscious understanding. It goes on subconsciously. Farther down on your handout is the issue of the difference between our physical sense of self and our psychic sense of self. Zen training in particular emphasizes doing away with the disadvantageous aspects of our self-centeredness. And to understand how this is so, you need to know the difference between the physical body, which is your physical sense of self. The Greeks called it your soma, and your cognitive and your affective and your instinctual forms of self, which are your psychic sense of self, which the Greeks called our psyche. So soma and psyche are very different. I know because I can feel my arm that I have a somatic sense of self. But can you touch a thought? Can you reach out and touch your thought? Your thoughts are intangible. So our soma deals with tangible things, and our psyche deals with cognition and emotion and instincts, and these are intangible categories of functioning. Now, let's look at the self in operational terms and try to see how it operates in our daily lives. And to do so, it helps to divide the self into three operational subcompartments. The most obvious one is the I, the part of ourself that we know exists, we can feel it, we know that it's there, and we can watch it act. And these are all very adaptive functions. Similarly, the me is that part of ourself to which things happen. If I don't look carefully when I'm crossing a curb and going out in traffic, I'm going to be hit by an automobile and something very bad is going to happen to me. So this is an adaptive part of the self, our me. And similarly, the mind helps us identify our thoughts, our body parts, and our possessions. If we're going in the parking lot at Googleplex and trying to find our automobile, it helps to know which automobile is mine and where we parked it, because otherwise we'll be lost without our car. So these are all the adaptive good parts of having an I, me, mine. But there are disadvantages. There's a downside. There are cons to being a self. There are maladaptive aspects of the self that we should like to do away with. The first and the easiest to identify by our friends are our aggressive self. Our aggressive, arrogant self. We have another self. Here I am trying to get rid of myself, and I have this other self that is somehow in the circuitry. And this tells us how difficult it is to get rid of ourself. We have this echo self, which seems to have subsided. No. It needs to meditate more. So our friends know that we have an arrogant and aggressive self, but this part is sort of hidden from us. But the me part of ourself, this we recognize because this is our battered and our fearful and our anxiety-ridden self. This is the part that gives us high blood pressure and all kinds of physical and mental ailments. And how about the mine? The mine, of course, is also clutching. It's captured, self-indentured. It craves things. It overeats. It wants too much. And these are in short, the ABCs of the I, me, mine, the aggressive, besieged, and clutching parts of the self that we can do without. Now, as the new century dawned, a group of investigators at Washington University in St. Louis, Deborah Gusnard and Marcus Rakel, looked over a bunch of PET scans, PET scans that had been done in the past, and discovered something interesting. And here you're looking at a summary of what they found. Because we're looking now at the inside of the brain. Previously, we've been looking at the outside of the brain. Now we're looking at the brain from the inside, and you recognize that it's the inside because it's the right hemisphere, and here is the corpus callosum that has been cut, the bridge between the two hemispheres. And what they found was that there were two hot spots in this inner part of the brain at rest. Their subjects were trying to relax, not do anything mentally or physically. And here was a hot spot in the medial prefrontal cortex, and here was a hot spot in the medial posterior parietal cortex. Front of the brain here, back of the brain here. Notice, by the way, the other centered allocentric pathway coming along here through the under part of the occipital and medial temporal cortex. And similarly, the other major hotspot was here in the angular gyrus, which, as we've noticed, is along this egocentric pathway that leads up to the superior parietal lobule. So here at rest are 3 hotspots. What happens when the subjects are then given a task which requires them to be introspective and to look into their self? These hotspots become even hotter. And various lines of evidence suggest that these hotspots, in short, are engaged at least partially in generating our sense of psychic self-identity and in relating this identity to our environment and to ways to navigate through our environment. So if you ask, what are these hotspots doing anyway? One might suggest, by way of speculation, that this is how you remember where you were born, what your bedroom looked like in your early formative years, where you went to high school, who your friends were in high school, where you went to college, and what your office looks like at Googleplex. This is where you fit in to your long narrative history and into that part of your environment which you lay down with circumstantial details so that you know how to find your way around your environment. But now, what happens when the subjects are given an acute task, an acute task that requires them to be very attentive to their external environment? If you remember the first slide with the self and external environment, you'll know and can anticipate that these hot spots become cooler. These self-hot spots become cooler when attentiveness is required and demanded by events in the external environment. And this has since been borne out by functional MRI. You're looking here at the top slide at the functional MRI scans, and here you're looking at the left hemisphere with the frontal lobe here and the occipital lobe here, and here is the posterior cingulate cortex back in the medial parietal lobe, and here's the medial prefrontal cortex, and here's the angular gyrus. So that this is a resting functional MRI scan, and we still have these 3 major hotspots. But now the subjects are inside the functional MRI scanner for 300 seconds or 5 minutes. And we see something fascinating, because we see that when the cool spots get hotter, the hot spots get cooler. And when the hot spots get hotter, the cool spots get cooler. And this is happening in this subject about 3 times a minute. Now, this is a very, very slow cycle, a endogenous, intrinsic cycle of the brain. It's not clear exactly what the mechanism is, but it's probably a combination of some metabolic cycle and some bioelectric cycle. It's much slower than the breathing rate of, say, 18 per minute, because this is only 3 per minute. Where could such a basic rhythm come from? And that, of course, is an interesting problem for neuroscientists to settle. And if you're wondering about the IPS, which is cooler, and the FEF, which is cooler, and the TPJ, and the inferior frontal cortex, which is cooler, rest assured that 20 minutes, 20 seconds later, things will be different. And here, 20 seconds later, is the evidence of a spontaneous reciprocal shift in the other direction. As the hot spots get hotter, the cool spots get cooler. Question?
Are the subjects doing anything during this?
No, this is spontaneous. The subject is not trying to do anything. This is an involuntary, spontaneous, endogenous, reciprocal shift that's going on by itself. Thank you for your question. So here is the cooler angular gyrus and the cooler medial posterior parietal and the cooler medial prefrontal cortex. And here again, as a reminder, is the reciprocal function we've been talking about. Now, the question then might be, those of you who meditate and who go to a meditative retreat, let's say you've gone through a day-long retreat or a weekend retreat, and then you've gone for a 7-day retreat. You're very relaxed and yet very receptive, very acute, very sensitized to your environment. And you've been doing this not for a week or so, but you've been doing this for some years. What would happen if you're just there, relaxed, in a receptive mode of attentiveness? Well, speculation here is a model to think about. Here is your allocentric mode of other referential attentiveness, going up and down, maybe 3 per minute. And here is your self-centered mode, going up in a reciprocal fashion, spontaneously. And then all of a sudden, a triggering stimulus comes from the outside. A triggering stimulus. A triggering stimulus has been described in Zen terms and Buddhist terms for many, many centuries. For Zen Master Ikkyu, who was meditating out in a boat, in a rowboat, out in the center of Lake Biwa in Japan, at night, the triggering stimulus was a bird that flew over and above him, a bird that he was unaware of. And the bird said, "Ha!" And Zen Master Ikkyu dropped into a sudden, extraordinary state of consciousness. Why? Well, we've seen that there is this reciprocal arrangement that goes on spontaneously, and we're speculating that his allocentric, other referential attentive processing would be captured and very hyper-attentive. And similarly, in the reverse reciprocal fashion, there would be a deactivation of his self-referential processing, which is in red and down here. And after a variable but unknown period of time, because time would drop out, his allocentric processing would be at a higher level, and as a residua during the afterglow phase, his egocentric processing would be at a very low level, and much of his prior maladaptive self would have been cut off. Cut off? Question?
How long does the afterglow last?
A variable period of time, but I would say anywhere from hours to a few days. Thank you for your question. I've just come back from Beijing, where I was given, to my surprise, this ceremonial sword. I thought it might interest the audience as a curiosity, but it also helps me explain how the sword cut that is described in the old literature, which is the sword of the Bodhisattva of enlightenment, Manjusri, how it operates and nicely slices off at just the right parts our sense of physical and psychic self that is disadvantageous to our well-being and to the well-being of others. Now, you may think it odd that any quasi-religion or quasi-philosophical or any other system of human endeavor would speak of a sword cut as a metaphor for a state of consciousness that would supervene. But this is the same way that my Zen master described such a moment to me, and the technique that he used went something like this. He said, a cut will open up in the mind. And to illustrate the depth of the cut, he put both of his hands down in this manner and touched his fingers to indicate a big, long, V-shaped cut in the mind. So we are talking, and there is a word in Japanese, kirei, which describes such a cut in the mind. Now, if the self vacates the center of consciousness, which it does, and in the center is an insight that comprehends all things in the outside world as they really are in the absence of self. And if there's no fear at that moment and no time and proprioception, the physical sense of self is unregistered, and if perfection is registered throughout the outside world at that moment, how is it possible that such a moment can occur? Again, we're talking about a model explanation, but the model begins with the thalamus. But what are we looking at here? We're looking at the left side of the brain, nose here, back of the brain here. We're looking at the thalamus, which is a paired structure. This is the left thalamus. And we're seeing the largest nucleus in the whole thalamus, which is the pulvinar. And the pulvinar on the model that you have there is indicated in a yellow-orange manner. If you see a yellow-orange spot, you're looking at the pulvinar. What does the pulvinar do? The pulvinar specializes in salience. That's the quality that enables the foreground item of interest to leap out and the background to subside and become the background. So the pulvinar is a very smart nucleus to have at the onset of all of our perceptions. Now, what you're looking at in color is mostly the dorsal part or the upper part or the northern part of the thalamus. And the other item of interest is the lateral posterior nucleus, and it's connected with the superior parietal lobule, which is where we organize our physical sense of self. In front of that are the three limbic nuclei of the thalamus. Through these three nuclei come all of the messages that rise up from our hypothalamus, our hippocampus, our amygdala. All of our emotional life passes through these three limbic nuclei in the front of the thalamus. And it so happens that each of these three nuclei are the passageway up to those three hot spots in the cortex, which are our sense of self. So the way the circuitry is arranged in the brain, all of the information which comes up from the limbic system and comes up in a bottom-up manner, that comes up through the limbic system and drives our cortex with all of our wants, all of our attachments, all of our emotions, first goes through these three limbic nuclei in the front of the dorsal thalamus. So we're talking about the dorsal tier first, but notice the ventral pulvinar remains, as does the rest of the ventral nuclei, and the ventral pulvinar goes up to the fusiform gyrus and all of the other information that passes along the allocentric, other-centered kind of processing. So then, how is it possible to drop out all of this dorsal thalamus and therefore rid ourselves of our anxieties and our sense of self? And the answer is that it is not possible. It's not possible unless you pay attention to another nucleus in the thalamus, which is the reticular nucleus. Think of the reticular nucleus as a cap that fits over the rest of the thalamus, and because it has many GABA, gamma-aminobutyric acid nerve cells in it, it exercises an inhibitory role on the rest of the dorsal thalamus. So because the thalamus and the cortex normally operate in an oscillating mode very quickly back and forth, the reticular cap enables the thalamus to shut down its thalamocortical system and to cut off our sense of self. Now you may say, what is the evidence for this in my own experience? The evidence for this in your own experience is that what happens when you go into your bedroom, turn out the lights, and drop off to sleep in the evening at night. Why do you fall asleep? Your vision drops out, your hearing drops out, your sense of physical self drops out, all courtesy of your reticular nucleus in addition to other circumstances. And why is the thalamus important? It's important because everything that you have experienced since you first sat down in this chair this morning, all of your perceptions have had to go through your thalamus in order for you to understand in the cortical level what's going on, with the exception of smell. And if you smell the coffee or the onions coming from over here, that's only because smell is the only exception. All the rest have to go through your thalamus. Now, like the rest of the Western world, the people in Holland were used to a door that operates as a unit from top to bottom until about 1600. And then some Dutchman said, hey, why don't we design another kind of door? Let's design a door that is hinged at the top and independently at the bottom, so we have more options. And if our wives are inside here and the kids are down here playing at the doorstep, she can look down and watch the kids. Or if it's a very hot day and we want to get some cool breezes from a distant source, we can close the top part and open up the bottom part and let the cool breezes come in and sweep along the floor. And if we want to close off the world at night in security, we can close both halves of the door as we drop off to sleep. The Dutch door is a metaphor for the way the dorsal thalamus opens and closes at different kinds of days. Now, there are some triggers of historical interest. The first, of course, is the moment, the episode involving Siddhartha Gautama about 2,500 years ago, who was meditating beneath the Bodhi tree in the pre-dawn hours when he looked up and saw the morning star. What is the morning star? The morning star was well known to the ancients. The morning star is the planet Venus. And this is the way the planet Venus was painted back in the early Chinese dynasties. She was painted as a white goddess, and as an indication of the harmony that was involved in her being, she is shown holding a lute. And as further evidence that she was present in the early morning hours, if you look up here, you can see that she has a rooster in her crown, evidencing what goes on in the first part of the morning. And next time you go up north and visit Seattle, do visit the Seattle Asian Art Museum, because in the Asian Art Museum you will see this statue which is entitled A Monk at the Moment of Enlightenment. You'll notice that like the Buddha who looked up and saw the morning star, this monk is also shown looking up at the moment of enlightenment. The technique of looking up as a meditative practice is well known in Tibetan Buddhism. And when Mathieu Ricard was here in 2007, about that time, he was also writing a book about Shabkar, an enlightened sage in Tibetan Buddhism in the 19th century. And what Shabkar had to say is this: I raised my head looking up and saw the cloudless sky. I thought of absolute space, free from all limitations. and then experienced a freedom without center, without end. In translation, the cloudless sky is the sky that is free of all delusions. Absolute space without limits is the space that extends around us as allocentric space. The freedom is the liberation that is part of an enlightened state, a moment. Without center means no self is in the center. Without end meaning infinite. And so as we go out the door through which we entered, I thank you for your attention.